Power generation through photovoltaic or PV cells. PV cells, also known as solar cells, are assembled into a solar PV module. PV modules, also known as PV panels, are linked together to form an enormous array called the PV array to meet a specific voltage and current need. A PV module is a critical component in any PV system that use direct current or DC electricity. PV modules can be linked together in series and parallel to meet a given system's voltage and current requirements. The main types of PV technologies are crystalline silicon, cadmium telluride, copper, indium, gallium diselenide, perovskite, multi-junction, and organic. The focus of this video is on crystalline silicon PV modules. Crystalline silicon PV cells are the most common solar cells used in commercially available solar panels. In 2016, 70% of US utility-scale PV capacity used crystalline silicon modules. For structural stability, crystalline silicon modules use a single glass sheet and an aluminum frame that weighs less than 3 kilograms per square meter. Single crystalline silicon, also known as monocrystalline silicon, and multicrystalline silicon, also known as polycrystalline silicon, are two forms of crystalline silicon utilized in the production of PV modules. Despite having lower conversion efficiencies, polycrystalline silicon PV modules are still more efficient than single crystalline silicon PV modules. There are many applications where space is limited, and crystalline silicon solar cells provide a high efficiency level. Crystalline silicon PV cells have laboratory energy conversion efficiencies over 25% for single crystal cells and over 20% for multicrystalline cells. However, industrially produced solar modules currently achieve efficiencies ranging from 18% to 22% under standard test conditions. Crystalline silicon is typically the technology of choice for solar PV projects developer because of its higher cell efficiency, a space-efficient design, and long module lifetimes. Thin film modules, however, are often less expensive than crystalline silicon and can be more attractive to some projects developer. Thin film modules also can be more flexible, lighter, and easier to handle than crystalline silicon is a semiconductor of electricity with chemical and structural properties of a crystal lattice, enabling crystalline silicon solar cells to efficiently convert light energy into electricity. Crystalline silicon modules are also inexpensive because silicon is relatively inexpensive. The benefits of crystalline silicon solar cells include maturity. Crystalline silicon solar cells have been around since 1950s and are widely available and efficient. The second benefit is performance. A standard industrially produced silicon cells offers higher efficiency than any other mass-produced single-junction device. Higher efficiency reduces the cost of the final installation because fewer solar cells need to be manufactured and installed for a given output. The third benefit is reliability. Crystalline silicon cells reach module lifetime of 25 plus years and exhibit little long-term degradation. The last benefit, abundance. Silicon is the second most abundant element in Earth after oxygen. For more information, you can check Department of Energy Crystalline Silicon PV Cells website.